Let's stop that question 14. Start with 15. Abdullah Milham. Abdullah.
Yes, mister. Yeah.
Okay. Read question 15, Abdullah.
The length of a certain wire is kept the same while its radius is doubled. What is the new resistivity of this wire?
Yes.
Doesn't change. Kept the same.
Yes. Why? I can explain why.
As you say in the question, the wire kept the same while its
So
radius is doubled.
the wires kept the same. This means we didn't change the material or the type of the wire, and resistivity is connected to the type of the material. It only changes with changing the material. For example, copper has its own resistivity, aluminum has its own resistivity, and so on. Thank you, Abdullah.
Yep.
Okay, for question 16. Stick randomly, Karim.
Yeah.
Okay, Karim. Question 16. Can you answer it?
The length of a certain wire is doubled while its radius is kept constant. What is the new resistance of this wire? Is it just the same?
It says the same. The length of a certain wire is doubled while its radius kept the same. What is the new resistance? Not resistivity, Karim. Resistance depends on the dimensions of the resistor itself. So you can have copper with 5 ohms and 7 ohms and so on. The resistance changes with even the same material because it depends on the dimensions of the material or the conductor itself. It's something different from resistivity. Resistivity like density, something like this.
So is it gonna be like it is 2 times as large?
Yes, because we know that the resistance is directly depends on the length of the wire. Let me open the. So we said yesterday that the resistance depends on 2 things. R resistance R directly proportional to the length and inversely proportional to area. We kept area the same, so the relation between resistance and L is directly proportional. If we double L, if we double the length of the wire, the resistance must be what? Must be doubled. If we bring resistance with length L, then we double the L, keeping the area the same, so this will double the resistance. So the answer is, it is 2 times as large. Resistance will be 2 times as large. But if in the same problem, if we say resistivity, which is rho, it doesn't depend on the dimensions, length and area, so cross-sectional area. Rho resistivity depends on the type of the material only and temperature. Okay, so you will have a resistivity for copper, a resistivity for iron, a resistivity for each material. It has its own resistivity. Let's go for question 17. محمد بودي. محمد بودي. مهند. مهند. Okay, Mohammed, question 17, read it.
The length of a sphere is doubled, and at the same time its radius is also doubled. What's the new resistance of the half as large?
So the length of a certain wire is doubled, and at the same time its radius is also doubled. So you have to do this so you're confused, you don't subtract. You double the resistance, and at the same time you do the radius. We don't have radius here in this equation, so we have to convert area into radius, which is area equal what? By r squared. So we can replace, because r is directly proportional, area, cross-section area, proportional to the radius squared, we can replace this relationship as follows. R directly proportional to length over r square, radius square. And let's see what happened. And the problem, length of the wire is doubled, and same time radius is also doubled. So we double this one. So this is the original resistance, this is the original length, and this is the original radius. Now we, in the red, I'm going to make changes to see what is the new resistance. So we double length, the resistance, the original resistance will be also doubled, multiplied by 2. And we double r, so r squared, double it, multiplied by 2, but it's 2 squared. So this means u increases it 4 times. And inversely proportional, our radius is inversely proportional to resistance. So if r increases 4 times, the resistance must be decreases to 4 times. So the new resistance, I make it in blue, compared to the original resistance, which is in black, equal not this one. So this resistance, the original one in the black, will be doubled and decreased to 4 times in the same time. And here 4. So we can cancel out 2 and here half. So the new resistance R equal 1 over 2, which is half of the original resistance, which is in black. So that's the answer. So what happened again? This is the black one, is the original resistance R, and here this is the original length L, and this is the original radius R squared. We double length, so the original resistance will be doubled, and we double radius, don't forget it's squared, so it will be increased 4 times. Increasing resistance or radius 4 times will decrease resistance 4 times. So the new resistance R, I make it in blue, or you can call it R2, there is a new resistance, will equal the original one multiplied by 2 over 4, which is half, multiplied by half. So the original resistance equal half of the, or the new resistance equal half of the original one. So go back to the answer. So he's asking about what is the new resistance of the wire. The new resistance, the one in blue that we do it in blue, that we write it in blue, equal half of the original one. It is half as large. His answer is D. That was your answer, Muhammad?
Yeah, what was my answer?
Yes. So the answer is what? Answer is D. So let's go for 18. Yahya? Yahya? Yahya. Omar.
Yes, hello.
لا Omar. Yes. Question 18 Omar.
The length of a certain wire is doubled, and at the same time, its radius is reduced by a factor of 2. What is the new resistance of this wire?
The length of a certain wire is doubled. This is the length, and at the same time its radius is reduced by factor of 2. What is the new resistance? What is the difference between 18 and 17? You know, it's doubled, and at the same time its radius is also doubled. Oh, this is reduced, sorry. So what's the answer, Amr, for this one? We have here, we increase the distance and we reduce the radius by factor of 2. Can you say it, Amr? Can you do the same as we did here? This is the original one, and it's directly proportional to length and inversely proportional to radius. Here we will do what? We double length, so this one will be doubled, multiplied by 2. And we reduced radius, so 2 by the factor of 2, means reduce 2. But it's squared, so it will be 2 squared. So it reduced to the factor of what? 1 over the total factor 1 over 4. Because here 1 over 2 squared equal 1 over 4. So this one, if this reduced by 1 over 4, this one will increase by 4. So you will increase it by 4. So what is the new resistance, Omar, right now? R equal what? 2 multiply 4, which is 8, as the original one, which is what? R. So the new resistance equal 8 times the original one. So the answer is D, it's 8 times as large. Answer is B. Omar, you didn't answer this one. Can you answer question 19?
Okay. Which of the following quantities is equivalent to 1 ohm?
Yes. 1 ohm.
D.
Yes, 1 volt divided 1 ampere. صح. That's true. Bravo عليك. Because we have here what? We have here, he asked about resistance, which is a measuring unit of, asked about ohm, which is a measuring unit of resistance, and resistance equal, according to Ohm's law, voltage divided by current I. So this one is 1 ohm, so 1 ohm equal 1 volt divided by 1 ampere. So it's equal volt divided by ampere. And the answer here, 1 volt divided by 1 ampere. Thank you, Omar. Kumail.
Yes.
Okay, Kumail. Yes, this one, question 20, read it.
If the length and diameter of a wire of circular cross-section are both tripled, the resistance will be?
Both tripled. You will do the same process. Tripling the length will triple the resistance. Let's do it. You can do it and tell me the answer. So this is the original resistance, R. Again, you have to follow the same process, directly proportional to length and inversely to R squared.
2 squared. So you'll times 3.
Here we multiply by 3. So
and
this one also times 3. And this one increased by 3 too.
Times 9.
Increase 3 times, which is 9 times. So this increased 9 times, this must be decreased 9 times. So divided by what? 9. So the new resistance, because both of them increased by the factor of 3, R equal 3, we can cancel it out, it's 1 over what? 1 over 3, 1/3 of what? Of the original one. So the new resistance is smaller than the original one by 1/3. 1/3 of the original one. So that's here, the resistance will be 1/3 what it was originally. This is the answer. The answer is what? The answer A is B. Kumeli will answer this question 21.
Didn't I just answer a question?
I didn't hear your answer, but if you don't want to answer it, we'll pick someone else.
I was answering the whole time, mister.
Okay. I just didn't hear you. Faisal?
Yes.
21.
Consider two copper wires of equal cross-sectional area. One wire has 3 times the length of the other. How do resistives of these two wires compare?
How the resistivity of these two wires are compared? He asked about not resistance, but resistivity.
It's not. I don't know.
Let's go back to this one and see what is resistivity. Let's add a new one. Resistance equal resistivity rho multiply L divided by area A. This is how to find, or this is the formula to find the resistance. So we have length and A, those are the dimensions, but rho here, which is called resistivity, it depends only on the type of the material, as exactly like density. Density equal what? If you want to look at I'm sorry. If you wanted to calculate density, it's equal mass over volume. But density does not depend on mass or volume. Density depends on the type of the material. This is for density. Similarly, here resistivity is some physical feature or some feature that depends only on the type of the material. It doesn't depend on the dimension L or A. It depends on the type only. So for each, what I mean that for each material, for each matter, you have a resistivity. For copper, you have a resistivity. For aluminum, for air, for any material, you have its own resistivity.
So if it's the same, it'll be the same. If
yes.
It's the same material.
So they are both from copper, so both wires have the same what? The same resistance. So the answer is A. Question 22. And Ahmad Anwar. Ahmad. You don't have a mic today. It's okay. So let me pick someone else. Ahmed al-Mish'al. Ahmed al-Mish'al. Ahmed, question 22.
Consider two copper wires of equal cross-sectional area. One wire has 3 times the length of the other. How does the resistance of these two wires compare?
Consider two copper wires equal cross-sectional area. One wire has 3 times the length of the other one. So he only changed the length. One of them has 3 times the length as the other one. And he asked about the resistance. We don't need to make a question because it's easy. So what is the answer for this one? We can do the calculation, Ahmed, like this. From here, we said that R directly proportional with what? Length over area. We increase this length by 3 times, only length by 3 times. So resistance will also increase by what? By 3 times. So the wire with the longer wire will have a greater resistance by 3 times. So what is the answer here?
So the longer wire is 3 times the resistance of the shorter one.
Yes, this is the answer. The answer is C. Thank you, Ahmed. So this is the same. I'll look something new for that. Oh, this is a new one. Let's pick someone else to answer this question. 25. Hassan? Hassan?
Yes.
25.
The current through a resistor is increased by a factor of 4. The power dissipated by the resistor increases by a factor of 16.
طيب. We have here a relation between power and current. So what is the relation that gather both of them? Power and current.
P equals I square multiplied by R.
Bravo عليك. Power equal I square multiplied by what? Multiplied by R. Why did you choose this one? Because we have a resistance mentioned in the problem, we have current and we have power. So in the same resistance, if you double the current, would I double it or increase 4 times? Let me see the problem. When the current resistor is increased by factor of 4 times, not doubled. So the relation, we can say that the relation between B and I from this one, when you have a resistance and we double the current that flows through this resistance, you mentioned the resistance, remember that. So we have the same resistance and we increase the current by 4 times. What happened to the power? We can apply the same method that we did before. Power is direct conversion to I square. So we increase the power, the current 4 times. 4 times mean what? 4 square, so the power will be increased by 4 square, which is 16 times. Thank you, Hassan. So increased by factor of what? 16. The answer is C. Which of the following quantities is equivalent to 1 watt? So this is another question. Let me pick someone to answer it. Khalid Badr. Khalid. Khalid Badr. Guys, your exams will start on the next Sunday, grade 12. Grade 12. شباب.
Yes.
You will have the first. What are the first subjects that will have it on Sunday?
I believe physics.
Huh?
I believe physics.
Are you sure from that?
Yes, let me check.
Check for that. What is the first subject that you have? You start with physics. Okay.
We have physics.
So, okay. طيب مشعل. مشعل. يا مشعل. No, I can't put absent. Muhammad Budi. Muhammad Budi also is not here. Muhammad is not here. And is not here. Let's start from the beginning again. Abdullah Milham. Abdullah Milham. Abdullah. يا عبد الله. أحمد أنور الملا. أحمد أنور. Oh yes, I forget that you don't have mine. I'm sorry. طيب أحمد توفيق المشعل. أحمد توفيق المشعل.
Yes.
Ahmed, which one of the following quantities is equivalent to 1 watt?
1 watt.
Mm-hmm.
Let's see.
1 volt multiply 1 ampere. Yes, let's see. Because we, by the way, we have a lot equal to 1 watt. This question is maybe confusing for some of you. We have many equations for power. Power equal IV. Power equal I square R. Power equal V square divided by R. And power equal E, which is energy consumed or dissipated, divided by time. All of this is power, is watt. Let me type it here. Watt, measured in watt, in watt, in watt. And what is equivalent to all of this? So, I measured in ampere. Volt multiplied by volts. Voltage measured in volts. So, what is equivalent to ampere multiply volts? Again, watt equal to I square R, so which is ampere square divided by R divided by ohm, another equivalent unit to watt. This is voltage divided by R, but voltage square, so this is volts square divided by ohm, equivalent to watt. And here, energy measured in joules and time measured in second, also equivalent to watt. All of these are units that is equivalent to watt. Because as I told you, we have many formulas or many equations to calculate watt. So that's the units. The one that we have it here, ampere multiply watt, in this problem or in this question, we have voltage multiply or volts multiply amps, which is equivalent to 1 watt. One kilowatt hour, and we have studied this. So. Let me pick someone to answer it. Faisal? Faisal? Yeah, Faisal. فيصل مش هنا. لا مش كومي. حسن بعدين كريم بعدين
Yes.
حسن يزيد. اوكي طيب a kilowatt hour is equivalent to
C. Yeah, C.
kilowatt hour equivalent to joule per second.
D.
Huh?
D.
Kilowatt hour is a unit for measuring energy like joules, and it equals equal to 3.6 million, which is this one. This is 3.6 million, which is something like this. I think I write it to you here. That's it. 3.6 million. If you multiply by 1 million, it will give you 3, 6, and beside it 5 zeros. That's 3.6 million. So both of them are units to measure what? Energy. So the answer here is what? Not C, it's D. This is joule per second and unit of power, while kilowatt hour is not a unit of power. It's a unit for measuring energy consumed. So the answer is D. 28. 28. Karim. Karim. كريم يا كريم اختفت الشباب. خالد 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 كريم خالد كريم كميل كميل.
Mister, I'm back. Did you call me?
Yes, I called you.
Okay, sorry.
This is the last question. Answer it and then you can leave. 28.
If the resistance in a constant voltage circuit is doubled, the power dissipated by that circuit will...
He mentioned voltage here, constant voltage and resistance and power. So what is the formula that gathers resistance, voltage and power? Resistance, voltage and power. What is the relation that gathers all of these? Do you know it?
Resistance, power, and voltage.
That's it. Resistance, voltage, power. So this is the relation between them. The voltage, resistance, power. If we double, yes, if we double what? Resistance is constant, voltage constant, resistance is double. What happened to the power dissipated? If we double resistance here in this one, you have to use this one, particularly this one. You mentioned this three. You can't use any
So
one
the
of these.
voltage is constant and we double the power. We double the resistance.
So the power will what?
It'll be half.
Yes, it will be half. It will be decreased by the factor of 2, it will be half. So the answer is what? Increased by factor, decreased to 1/2 of the original value. The answer is what?
C.
Answer is C. Thank you guys for listening, and I'll see you tomorrow, inshallah. Have a nice day. Bye bye.